Only few percentage of students can solve this question on the board. Now, the good news is that we are going to get the understanding today. But the question is 3 raised to the power of x is equal to x raised to the power of 9. If you look at this question, there are just two terms. One is at the left and the other at the right hand side. And they are all written in their exponential form. 3 to the power of x and x to the power of 9. But at this point, there is a problem. The problem is that a number is carrying a letter, while a letter is carrying a number. It shouldn't have been that way. So our aim is to ensure that this number will carry a number and this letter will carry a letter. So that in the left hand side of the equation, you are going to have number raised to the power of number. While in the right, you are going to have a letter raised to the power of a letter. Let's achieve that. Solution. Now, in my left hand side, I have 3 raised to the power of x. While in my right, I have x raised to the power of 9. I want to ensure that in my left, we have just a number alone and not a letter. So to achieve that, I'm going to divide both the left and the right hand side by x. Whatever you do to the left hand side, do the same thing to the right hand side. So that becomes x divided by x and 9 divided by x. Now, x divided by x is going to give you 1 as the power. So at the left, we are having 3 raised to the power of 1, which is basically the same as 3, which equal to x raised to the power of 9 over x. Now, in the left hand side, we have just a number, but in the right hand side, we have a number and a letter. Let's do the same thing to the right hand side to ensure that the right is with letter and letter only. So that becomes times 1 over 9 and times 1 over 9. This 9 and this 9 will cancel out. So we are going to be left with, from here, 3 is raised to the power of 1 times 1 is 1 divided by 9, which equal to, over here, x. 1 divided by x. 1 divided by x. So we have achieved the first goal. At the right hand side, I have a number raised to the power of a number. At my left hand side, I have a letter raised to the power of another letter. At this point, we don't have a problem with the right hand side. The only problem we are having now is with the left. We are going to leave this person because we don't have any issues with it and deal with this person. So this person is 3. 3 raised to the power of 1 over 9, which equal to x raised to the power of 1 over x. The reason I'm saying we don't have any issues with the right is because we are not going to work on this. We are going to leave this to the final result. Now, what we are trying to establish is to ensure that since the right hand side is x, raised to the power of 1 over x, we observed that the base and the denominator of the fractional power is the same. Now let us examine the power. The power here is 1 over 9. 1 over 9. This 1 over 9 can also be written as 1 times 1 over 9. It's the same thing. Because we want this and this to be the same, we can simply say that let this one represent 3 divided by 3. Because 3 divided by 3 is 1, so we can use 3 over 3 in place of 1. Then times 1 over 9. Let's bring this to this place. Remember, 1 over 9. Take note, 1 over 9 is literally the same as 3 over 3 times 1 over 9. I repeat, 1 over 9 is literally the same as 3 over 3 times 1 over 9, because 3 divided by 3 is 1, then times 1 over 9, which is still 1 over 9. But I'm bringing this power to replace this 1 over 9 here. So 1 over 9 gives this. Because 1 over 9 is this, I will say let 3 raised to the power of 3 over 3 times 1 over 9 equal to x raised to the power of 1 over x. Now this could also be written as 3 raised to the power of 3 times 1 over 3 times 9. 3 times 1 is 3. Numerator, 3 times 1 is 3. Now denominator, 3 times 9 is 27. And 3 times 9 will give 27. So this yields x raised to the power of 1 over x. If I put this in bracket, I'm going to obtain 3 raised to the power of 3 raised to the power of 1 over 9, 3 times 9, which equals x raised to the power of 1 over x. Now this is the same as 3 raised to the power of 3 means 3 times 3 times 3, which equals 27. So I'll write here 27 is raised to the power of 1 over 3 times 9. 3 times 9 is 27. So 1 over 27, which equals to x raised to the power of 1 over x. By comparison, we observe that the base is 27 raised to the power of 1 over 27. And over here, the base is x raised to the power of 1 over x. Because the two sides of the equation are the same, that is, the base and the denominator index is the same as this, we can simply say that x is now equal to 27. 27 is to x, 27 is to x, and 1 is to 1. Therefore, x is equal to 27.